Hello, welcome to my channel. This episode is about most common failure mode I see in Claude Code setups. Someone writes a CLAUDE.md file with rules like always use environment variables, never hard-coded secrets, never write production database without confirmation. They run a session, Claude hard-codes a secret or writes to the production. They go back and add more rules. Same thing happens again. The rules are not wrong. The problem is misunderstanding of what CLAUDE.md actually is and how Claude Code reads it. Once you understand the runtime model, what gets loaded, when, and how it completes for attention, you can write Claude.md files that actually work. And you understand immediately which constraints belong in the MD of Claude and which belong in a hook. This is episode 1 of Claude Code in production. Let us build the mental model. Before I show the solution, let me show the problem in detail. Because most people have the wrong mental model from the start. Here is a CLAUDE.md I see constantly. It has a list of rules at the top. Always use environmental variables for secrets, never modify production data without explicit confirmation, always write tests before implementing features, never use git force push. These rules look reasonable. A senior engineer would follow all of them without being told. The question is, does Claude Code follow them reliably? The answer is sometimes. And sometimes it's not good enough for production constraints. Here's what actually happens. When a session starts, Claude Code loads the CLAUDE.md into the context window as text. It is part of the prompt. The model reads it same way it reads everything else, as context that may or may not be relevant to the current task. When you ask Claude to refactor a function, the rules about Git and production data are not particularly relevant to that context. The model pays less attention to them. When you ask Claude to commit and push a change, the force push rule becomes relevant, and the model is more likely to follow it. The rules are not being ignored because Claude Code is broke. They are being treated probabilistically, like every other piece of text in the context window, because that is what they are. Let's go to the code, look at the API project, and look at the CLAUDE.md. As you can see, it explains what the repository is, a content map, references, how to run it locally, tests, and the endpoints. And only there is a behavioral rule at the end. So, what is right mental model for what CLAUDE.md actually does? That's it. Here is the running model. When a Claude Code session starts, Claude Code reads your CLAUDE.md files and prepends them to the context window. Every turn, not once at setup, every single turn, CLAUDE.md is reloaded and re-included in the prompt on each message. This has two important implications. First, CLAUDE.md content completes for context space with everything else in the session. The conversation history, file reads, tool call results, the current user message. In a long session that has accumulated a lot of history, your CLAUDE.md is still there, but it is a smaller fraction of the total context. Long CLAUDE.md files cost more token budget on every turn. Second, the model reads CLAUDE.md the way a person skims a long brief before a meeting. If your instructions are buried in the paragraph of prose, the model may not surface them where they are needed. If your instructions are structured, clear headers, short lines, specific to the task at hand, the model processes them more reliably. This is why always use environment variables written as a paragraph prose behaves differently from a structured content map that says each file is for. The content map is structurally information that is always relevant when working with a code base. The behavioral rule is only relevant in specific situations. The mental model is CLAUDE.md's briefing document, not a rulebook. Design it like a briefing document. Even in that mental model, the content you put in the CLAUDE.md falls into 3 categories, and only one of them is fully reliable. Here are the 3 categories. The first category is structure. This is information about the project that is always relevant regardless of what task is being performed. File paths, folder layout, what each file does, what the stack is, which file is read before touching a specific area of the code base. This content wins attention reliably because it is useful on almost every turn. If you ask Claude to add a feature, knowing where the routes file is and what the data model looks like is immediately relevant. Structural information earns its place in CLAUDE.md. The second category is the reference. These are workflows, processes, and multi-step procedures. The proposal workflow in a job search vault, the episode production checklist in a content calendar, the deployment steps for a specific project. Reference content is not needed every turn, but when it needed, it needs to be complete and accurate. Reference content works well in CLAUDE.md as long as it's structured. Use headers and numbered steps, not prose paragraphs. The third category is behavioral. These are rules. Always do X, never do Y. Behavioral content is last reliable category. It depends on the model correctly identifying when a rule is acceptable and choosing to follow it despite pressure from the immediate task. It is not zero value. Well-written behavioral rules do not shift model behavior, but you cannot depend on them for hard constraints. The key question is, what happens if constraints is violated? If the answer is production data gets deleted or a secret gets hard-coded into a public repo, the constraints belongs in a hook, not in a CLAUDE.md rule. If the answer is the code styling is slightly inconsistent, CLAUDE.md is fine. Let's look at a real CLAUDE.md file from API project and application. CLAUDE.md file is here. Look, the structural category is here. So we have all the files that contains the core logic application. Then the reference, the second category. You can see it here. And in the end, the behavior, the cloud client usage pattern. Now let us look the hierarchy, because CLAUDE.md is not just one file. Claude Code loads CLAUDE.md from 3 levels. The global file lives at the claude/claude.md. This applies to every project on your machine. Use it for personal preferences that are true everywhere. Your name, your preferred code style, tools you always want available. Keep it short. Anything you put there is loaded for every session, so every byte has a cost. The project file lives at the root of your project directory. This is the main CLAUDE.md for specific project. It should contain the content map, the stack description, the relevant workflows for that project, and any project-specific constraints. Subdirectory files can live anywhere in the project tree. If you have a complex code base with distinct regions, a front-end and a back-end, or a data pipeline and API service, you can put a CLAUDE.md each subdirectory. When Claude Code is operating in that subdirectory, it also loads that file. This lets you keep the project level instructions concise and push domain-specific context down to where it's actually relevant. The merge behavior is additive. All applicable CLAUDE.md files are concatenated with the project level file first. There is no override or exclusion mechanism. Every file contributes its content. The particle implication: use subdirectory CLAUDE.md files to avoid a project level file that tries to describe everything. A 20-line project CLAUDE.md plus a 30-line front-end CLAUDE.md and a line backend, approximately 30 more for the backend CLAUDE.md, is better than a 100-line project CLAUDE.md that mixes concerns. Look at our example. That's why we have a API project CLAUDE.md file and an application CLAUDE.md file. This MD file for API project, this is for application. With the hierarchy is clear, the most important design decision is what belongs in the CLAUDE.md and what belongs in a hook. If a constraint can tolerate occasional violations, code style preferences, naming conventions, documentation habits, it belongs in CLAUDE.md. The model follows it most of the time. That is often good enough. If a constraint cannot tolerate violations, no destructive shell commands, no writing to production databases, no commit secrets, no modifying files outside the project directory, it belongs in a hook. Hooks run in a shell commands in response to tool events. They are not part of Claude reasoning. They execute outside the model and cannot be overridden by anything Claude decides to. The distinction maps onto a risk question. What is the blast radius of a violation? Low blast radius CLAUDE.md, high blast radius hook. There is a second category that belongs in hooks. Things that must happen reliably regardless of what the model is doing. Saving task state before compaction, logging every file write, running a linter after every code edit. These are not constraints on model behavior. They are automation that runs alongside every tool call. Hooks are the right place for them. The common mistake is trying to solve hook level problems with CLAUDE.md prose. You write never run rm-rf in your rules section. Claude follows it most of the time. One session. Under a long context with a lot of history, the rule gets less attention. The wrong command runs. The fix is not a better winner rule. It's a pre-tool use hook that intercepts the bash tool and checks for destructive patterns before execution. Episode 2 of this series covers hook in detail. For now, the rule is simple. Enforce at the shell level or trust it against guidance. Shall never means a hook. Guidance means CLAUDE.md. Let me show what well-structured CLAUDE.md looks like for a code project. Here's a CLAUDE.md template for a fast API backend project. This first section is structure. What the repository is, content map table with file paths, and one-line descriptions and the stack. This tells Claude what is working with before any task starts. This section is almost always relevant, so it earns its place at the top where it gets most attention. The second section is the reference. How to run the project locally, how to run tests, how to add a new endpoint, the specific steps developer needs when they sit down in a new session. These are consulted on demand rather than applied on every turn, so they can be longer than the structural section without causing problems. The third section is behavioral, and it's intentionally short. 2 or 3 lines about the code style, preferences, nothing more. Every behavioral rule added here is a rule what will be followed sometimes and ignored sometimes. If you cannot accept the trade-off for a specific constraint, it belongs in a hook, not there. Notice what is not in this template. No verbose explanation, no documentation of how framework works, no history of decisions. CLAUDE.md is briefing document, not an architecture decision record. Architecture decisions belong in the architecture MD or in a code commands. CLAUDE.md is about giving Claude the minimum context it needs to work effectively in this specific project. Let's go back to Visual Studio Code and episode 1 CLAUDE.md architecture. Let's check out the project CLAUDE.md file. It explains what the repository is. There's a content map, structural section, reference section, how to run it, and very short behavioral section. Now let me show what it looks like for a different kind of project. A knowledge vault rather than a code project. This is the CLAUDE.md for the Obsidian Vault I use to manage client work, job applications, and YouTube content. It's a different kind of project. No runnable code, no test, but the same structural principles applies. The first section is what is this repository and a content map, every file and folder, with a one-line description. This is the most important section because without it, Claude has no way to know where to look for anything. The vault has over 60 job posting files, 8 proposal files, 4 YouTube episode folders, multiple client project writes up. The content map is what makes any of navigatable. The second section is the proposal workflow, a numbered 10-step process for evaluating a job posting and writing a cover letter. This is reference content. Claude does not need to follow all 10 steps on every turn. It follows them when a proposal is being written. Having them as a numbered list rather than prose means they are parsed correctly when they are needed. The third section is the episode production workflow. How episodes are structured, where files live, what the published episode index look like. Same pattern. Consulted when needed, structured enough to parse correct. The behavioral rules in this file are minimal. A note about not using YouTube Studio Management URL in proposals. A note about not naming a specific client in public content. These are genuinely low blast radius. If Claude gets them wrong occasionally, nothing catastrophic can happen. High stakes version, the destructive command guard that runs in a hook in the underlying Claude Code setup, not as a prose rule in CLAUDE.md. Let's go to the examples, Vault project and CLAUDE.md file. This is a knowledge vault, and as you can see, what is this? The content map, structural section, reference section, and a behavioral section. The last thing I want to cover is the token budget, because the way you write the CLAUDE.md has a measurable cost in every session. If your CLAUDE.md is 500 tokens, that is 25,000 tokens spent on the context injection across a 50-turn session. Before a single line of code has been read, if it is 100 tokens, that drops to 5,000. This matters in 2 ways. First, it is literal cost if you are paying for API usage. Second, and more important for Claude Code users, it is context space that could have been used for file contents, conversation history, and tool results. A bloated CLAUDE.md crops out the actual working context. The discipline is every line in the CLAUDE.md should be structural information that is useful on most turns, or reference information that is worth the cost of loading even when not immediately needed. Behavioral prose that is sometimes followed has a high cost to reliability ratio. Remove it and move the real constraints to hooks. 3 specific things to cut from the most CLAUDE.md files I see: verbose explanation of why a rule exists. Claude does not need to rational, just the fact. Documentation of how the project was set up. That is a readme content. List of things that are obvious from the code. If the language is Python, you do not need to say use Python. The goal is a CLAUDE.md that senior engineer would look at and say, yes, this is exactly the briefing I would want to before picking up this project. Not a comprehensive manual, a briefing. Let me close with 4 things to take away from this episode. 1. CLAUDE.md is part of the prompt. It is loaded on every turn and competes with everything else in the context window. Design it accordingly: concise, structured, and useful. 2. 3 categories of content. Structural information works reliably. Reference workflows work well when structured. Behavioral prose works sometimes. Only use behavioral rules for low blast radius constraints. 3. Hard constraining belong in hooks. If you cannot accept a single violation of constraint, it does not belong in the CLAUDE.md. It belongs in a pre-tool use hook that runs outside the model. For use hierarchy, global CLAUDE.md for personal preferences. Project CLAUDE.md for the content map and workflows. Subdirectory CLAUDE.md for domain-specific context. Keep each level concise and purposeful. The templates and examples from this episode in the production Claude Code repository. In the branch episode 1 CLAUDE.md architecture. Links in the description. Episode 2 covers the hook, turning text constraints into shell level enforcement. Before I close, I can show the production Claude Code is on my GitHub repository. You can find them here for the first episode. So before I close this, let me show a project CLAUDE.md how it looks like, and a global CLAUDE.md how it looks like. So there is a validate CLAUDE.md py also in this repository. It's a token budget analyzer for CLAUDE.md files and reports estimate tokens, count per section, total cost, token cost, and cumulative cost across a multi-turn session. So if you check it out and like and share, and if you can use it, please use it. Don't hesitate. So this is the end for the first session. If you like this video, please hit like button and subscribe. Thank you. See you in the next session.